access Kibana through OIDC. It will mostly be about the demonstration. I will try to basically do everything from the ground up. So actually also set up the endpoint in Azure and deploy it to a cluster I created before. But more on that when we come to the demo part. First, the agenda, Open Distro security plugin. I just want to quickly mention what it is and how we use it. Then the long road to success. It took me some time to figure this out. And I want to point out what difficulties or some of the difficulties I encountered. Then we'll do the demo. As mentioned, that would be the biggest part, and lessons learned, what comes next in regards to mostly EFK. The OIDC thing is done for now. Open Distro security plugin. So Open Distro for Elasticsearch, which is a version or a release of Elasticsearch, open sourced, which anybody could get, has its own security plugin for authentication and access control, which Elasticsearch and related components do not provide on their own, or only with limited features. With Elasticsearch security plugin, Open Distro security plugin, you get node-to-node encryption, HTTP basic authentication, AD, LDAP, Kerberos, SAML, OIDC, role-based access control, index document, so everything you see right there. And we built it in because one of our customers requested the ability to implement better authentication and authorization. So we built the EFK stack app on top of the Open Distro security plugin. So the long road to success. Open Distro for Elasticsearch is complex and very sensitive. What I mean by that is debugging is tedious. Logs don't really show the actual issue. I will give an example on what we encountered, and what I mean by configuration is sensitive. And documentation is extensive, but not user-friendly. From the start on, I got the feeling that those guys really know what they're doing and have a lot of knowledge around authentication, but you definitely feel in the documentation that it's targeted towards people that have a really extensive background, and it's really hard to understand that stuff until you get your head around it. So it just takes time to get into it. Then it's definitely good documentation. So one example of sensitive configuration, who can tell me what the difference in those two config files is? It's a, yeah.
Authentication backend port? No.
No, at the end of the file, you see line 41 on the left example, which is missing on the right example. And this was one case that took us about 2 days to figure out. In the end, when we figured it out, it was 3 of us in a call. Pau sent me the right version, and which didn't work for him still, but should have been sufficient. And because I read somewhere that every configuration file needs to contain those four parts, which are under the key dynamic, it's HTTP, auth-C, and or three, those 3 components, and the auth-C. When I added the auth-C, it started to work, although it's an empty value. So that was the kind of stuff we had to work around. Yeah, so that was fun. Now coming to the demo. The procedure can also be followed along in the docs transform IO guides, EFK stack up OIDC. What I have already done is cluster goes 89882 is created, I installed Nginx IC with the app platform. I also installed Cert Manager. And you can see what the procedure is going to be. Register. First, we'll register on the Azure platform. Then we configure the whole thing. And at step 5, we deploy Kibana with the OIDC settings. All right, let's dive in. So this is the Azure portal. I'm sure Tobias is very familiar with it. So on the left, we go to Azure Active Directory, and here it's app registration. This is my test setup, Quentin's test setup. We're going to do a new config, Kibana EFK demo. Say OIDC. And yeah, those settings are fine. I'm quickly going to get the redirect URL, which I prepared. So it's basically the endpoint under which Kibana will be accessible with the auth OpenID login, I think, login path. We go register. So now that we are here, we want to get the client application ID, which is that one. And we want to get a client secret. The client secret we can get from certificates. New client secret description, Kibana. Let's make it valid for 1 year. Add, obviously, this one is done only once. Right. Next thing we have to do is to configure the JVT token. So in our setup, we configured it to take the group ID of users to identify its role. So the group ID will be passed with the JVT token, or the group IDs of that user will be passed with the JVT token. And in the role mapping, we will define this group ID to be mapped to a specific role. And everybody with that group ID will then attain that role. To do that, we just add the groups claim. In our case, it's a security group. Those we can just leave as default. We just want a group ID and add it. Right, and that should be that mostly. Okay, next we go to the command line. So here are all the configuration files we need. So as you can see, this is a completely new cluster. Here are the charts. So we did install Nginx Ingress Controller, and we did install Cert Manager app because it will be utilized by Kibana. Next step is creating the namespace, because we need to create some secrets inside the namespace before we deploy Kibana, so it can Kibana can, or the whole EFK stack app can consume those secrets as configuration. So kubectl, create namespace, and it's going to be EFK stack app. Okay. So now we'll quickly review all the secrets I defined. So first we'll do the config.yaml. So this is one of the secrets we're gonna, or the configurations which will be deployed as a secret that we're gonna use. I already filled out the Open Connect URL. This points to our Microsoft account, Microsoft accounts OpenID. And we need to populate it. Right, connect URL is already there. So that's basically it. Nothing really fancy here. What should be noted, as I mentioned, the auth C part in the end, although it's empty, is required. Otherwise, it won't work. And then we define a basic internal auth domain, which will just use the internal user database, and open auth domain that we define for OpenID with the OpenID Connect endpoint. Then we'll review the internal users. So this just defines two users that will be created on install, the admin user and the Logstash user. This needs to have a hash password, and for readability here, this is mentioned just after the hash. For the hash, you need to go to bcrypt, or you can go to bcrypt generator. And same goes for Logstash. This will also be applied as a secret. And then we have the roles mapping. So this is the part where we do map the all access role, or the all access permissions, to a backend role, which will be sent from a backend endpoint or authentication endpoint. In this case, we will map the group ID of a group that lives on Azure AD to the all access role. And these are some boilerplate roles. Basically, this file will be the default that will be applied if you don't supply a config file. But if you supply a config file, only the stuff that you define in the config file will be applied. So you have to basically take all the default roles if you want to have them available. And now I'm going to attempt to create all those secrets in the namespace. I hope this command works. Yep, so that worked. We have all those configurations. Thinking that should work. Yeah. So last but not least, we'll go into the values channel. So from the top, this is what we will supply to the HAPA to deploy the app. These are just some sane settings that we worked out, so EFK works just fine. Persistent size is a bit small, but for demo purposes is enough. Security config, here we see those secrets defined that we just created that will be mapped to the required points. Then next thing is with Kibana, we define the admin and password for how it will connect to Elasticsearch. Right, so here we need to apply some settings for the config. Open Distro security, OpenID client. It's the one I copied. So this is basically the application ID. And then here comes the secret we created. This is the endpoint we want to access Kibana through. This is the same as before, just the endpoint for our Microsoft account. And here are just the ingress settings, which also point, these are then basically responsible for creating the ingress and the certificate to access Kibana. And now we'll switch over to Hapa. As mentioned, this is on Ghost. So here we see Cert Manager app and Nginx Ingress Controller app already installed. We go here and EFK Stack app, configure latest release, and we supply the Orion values. And hope it works. So as observed multiple times, this can take a bit of time, and Fluentd will restart or fail a bunch of times until it actually can connect to the ES part of it, which takes some time to start up. So maybe as this keeps creating, we can go back to the documentation slides. So we went through the whole procedure. I can see, or you can also follow along on Teammate, how this is creating. Maybe I'll share again for Yasser to also join. Well, no, that didn't work. There you go. And yeah, what's to come? So lessons learned, Open Distro ES is powerful but difficult to wrap your head around. At some point we were 4 engineers in one call and kind of only by luck figured out how to do it or what was wrong. Reading things will only bring you so far. So especially with Open Distro security plugin, just kind of try to apply this stuff will be the thing that kind of gets you where you need to be. What comes next? So we want to implement admin certificates. They should be, so we have a POW created a tiny project that generates the transport certificates required for encrypted communication inside the cluster between the components. We want to extend it so it also can create admin certificates for the admin user. Basically, certificate-based authentication is one of the features that is, or one of the authentication methods you can implement with Open Distro security plugin. And we want to leverage those certificates, those admin certificates, to also implement a job or a similar mechanism to implement config reload, which currently is not possible, at least not by default. And there needs to be some improvements done for fluently integration. For example, those crash loops that we're seeing right now, these need to be kind of changed to more sane setup. And we're still waiting on creation finishing. It seems to work okay. Almost there. But maybe we can get to questions and check the results just after.
How long do you typically see that taking to actually come up? Not like, I guess, perfect answer, but just ballpark when you've been playing around with it.
How long what?
Like for that stack, so you deployed it and then we're waiting on it to like officially actually connect. How long do you typically see that takes? Like what's a normal, I guess, amount of time to expect when doing that?
So we'll see it right now, about 5 minutes.
Okay.
So it should be up in another minute or two.
Okay.
And you can count it. So when crash loop 4 comes around, then it's usually at the point where it will then, like Fluently will then start and be accessible. Other questions? As I feared, so there is one issue we encountered multiple times with the, no, DemoGod's not happy. So there is an issue we encountered multiple times with the secrets. So we have the Kibana auth secret, which does contain the password. Oh, username. So here it's correct. This should work fine. Oh, okay, I see the issue. The issue here, I have a white space at the end of this line, which will basically render this whole installation useless. What we need to do now is, I want to go through. If you want to, you can say stop, or we can just quickly follow along to debug this issue. So currently, as I mentioned, config reloading is not possible, which means if you have some issue with the configuration you deployed, you basically stuck deleting the app, then also deleting the EFK step Open Distro ES persistent volume claims. So the volumes are deleted because once the config file is read into the Elasticsearch security index, those won't be overwritten by changing the config. And that's one thing we want to work on for this config to be reloadable. So those values can be overwritten and we don't have to basically delete the whole storage for the thing to be gone. Obviously, you can do this through the API. You can change the value, but I don't have those kind of bits together to do it through the API, which would be more sensible. And we need the internal users in EFK stack. Yeah, let's just hope it's correct. No other questions? Yeah, so the endpoint would be, I would be already logged into Microsoft account, so I would access Kibana and would just be logged in. And currently, it's configured to redirect to the Microsoft OIDC backend every time you access the page. So this is something else we want to supply, and it's achieved by ordering those authentication methods in the security config file.